We will talk about viscosity now. So, what is the viscosity? Viscosity. Viscosity, or simply known as dynamic viscosity. Viscosity is a property of a medium or a fluid medium that measures the resistance to flow. Resistance to flow. And viscosity is the quantitative measure of that resistance to flow. Quantitative measure. So, viscosity is property of a fluid. It is a property of a fluid. Property. Sorry. Property of fluid, and it relates strain rate with shear force. With shear force. So the main reason behind the viscosity is the frictional force. Frictional force that occurs between the layers of fluid. Layers of fluid. Uh, we have, as we know that it relates strain rate with shear force. We have tau equals to mu, which is our viscosity, upon du by dx. This is the shear stress, and this is the strain. Hence, we have our viscosity is tau upon du by dx. This is our viscosity, or simply dynamic viscosity. And and our unit of mu is Newton second per meter square, and we have our one poise of viscosity, which is zero point 0.1 Newton second per meter square. One poise of this. We have our kinematic viscosity here. Kinematic viscosity. What is a kinematic viscosity? It is a measure of how much energy can a fluid carry. City of fluid. And how it is calculated? It is calculated using kinematic viscosity is dynamic viscosity upon density. So the unit of kinematic viscosity is one stroke, which is centimeter square per second. So this is how viscosity is calculated and measured. Since we have known about the viscosity, we will talk about the variation of viscosity with temperature. So if this is a very viscosity, and this is the viscosity at zero temperature, we have our equation, which is 1 plus alpha t, alpha and beta are constant. Hence from this equation we can see that as the temperature increases, its velocity decreases. Variation of viscosity with temperatures. And we will talk about Newtonian and non-Newtonian fluid. Newtonian and non-Newtonian. We can study about Newtonian and non-Newtonian fluid through this graph. If this is a strain rate and this is our shear stress, then we have this graph where Uh, this shear stress is proportional to strain is Newtonian. Now Newtonian is like this, where shear stress is proportional to nth power of shear strain, or simply strain rate. This is known as viscous non-Newtonian Newtonian fluid. Uh, Also, if we see on the similar graph here, where strain rate du upon dy shear stress, we have a the viscosity of oil is high, so oil is there, and water is there. The least viscous fluid is here, and this is how viscosity changes from the fluid medium to another fluid medium also. This is all about Newtonian and non-Newtonian fluids. Now we will talk about surface tension. What is a surface tension? Uh, it is a property of a fluid due to the molecular attraction, due to the result of molecular attraction. So it either it is a cohesion or adhesion. Surface tension is the result of cohesion. So suppose there is a fluid in the bucket, and we put a small tube inside of it vertically. So the meniscus could be like this, or it could be like this, depending upon the adhesive property of the fluid to this tube and the type of fluid. The property of a fluid, where it is due to which it wants to maintain the minimum surface area is known as surface tension. And in this kind of analysis, this weight is balanced by the adhesive force. The weight of extra fluid is balanced by the adhesive force of this fluid to this surface of the tube. So if the angle here is theta, and we have the formula of 2 pi r sigma cos theta equals to, this is our surface tension, force per unit length, and this is our pi r square h, pi r square h gamma. So this is how our equation develops. I think this is all about viscosity, Newtonian, non-Newtonian fluid, and as well as surface tension. See you in the next video.